Use the properties of logarithms to evaluate each of the following expressions. If you haven't already, make sure you've written all of the properties of logarithms and write them down on a sheet of paper or write them down on flashcards because your goal is to try to memorize them. Once you have them memorized, then you can apply some of those properties and manipulate this following expression. First thing we're going to do is say this first expression is equal to log base 3 2 raised to the third power minus log base 3 of 72. Now 2 to the third power is just 8, so that's just log base 3 of 8 minus log base 3 of 72. Now, logarithm of a difference of logs with a common base is really log base 3 of 8 over 72, and that reduces to log base 3 of 1/9. But what's 1/9? What's 1/9 in base 3? That's log base 3, 3 to the negative 2. And then our final log property says that is actually equal to negative 2. You could try doing example B. If you need to, pause the video and try doing example B. The answer you should get to example B should be 2. How do we get 2? Well, how can we rewrite log base 2 of 36? What should we do with this 2 in front of log base 2 of 3? We're going to move that up to be log base 2, 3 squared. And of course, 3 squared is 9. So this is really log base 2 of 36 over 9. And that is log base 2 of 4. How we're going to rewrite 4? We're going to rewrite it as 2 to the second power, which of course is equal to this 2 right there. Let's look at the last two examples here, part C and D. Remember, the natural logarithm is basically log base e. So if it helps, you could even write the invisible e. But you do need to know that there is a base e down here, and then there is a base e down there. And we have a log property that simplifies this rather quickly. This is 6 plus 12. And you already know what 6 plus 12 is. That's 18. So the idea behind these expressions is actually to help you memorize log properties for future math classes. You're just trying to memorize these properties through practice of exercising. You're just exercising these properties over and over again and get it done to such a point where it just becomes muscle memory. So this one here, this is going to equal negative 8 plus 3, and you know that's negative 5. Let's do a recap of what took place. Let's see how many log properties you really used. If you have them memorized, you should be able to write them. Here's one of them. That's one of the log properties you used. Here's another one. Log, let's say, base b of m minus log base b of n. What's that going to be? That's going to be log of base b of m over n. So a number of properties you really used here. Some of you may have even used this one. You might have used log base b of b. And you can see the invisible exponent here is just 1. So some of you may have used that. What else could you have used? I think that's about it for this. For these examples on this particular set, you could even look at ln of e to the p. Well, that's just p as well. So you use a number of properties while simplifying these expressions. Mostly these four. Let's circle the final answers here. That's a final expression, that's a final expression, that's a final expression, and that's a final expression. Notice we didn't solve anything. In this case, you manipulated these expressions or you simplified them by evaluating it. You gave value to this first expression. The value of this first expression here is actually going to be 2. Evaluate means to give value to. To give value to this expression here, we gave the value of 18. Here, evaluating this expression, you got the value of -5. More importantly, you didn't solve anything. You just simplified an expression. With every expression, your work is an expression, 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 expression. There are no equations on this page except for the circled ones over here. But for these 4 examples, you are only working with expressions. Let's solve these equations. Let's find the missing value for x that makes the original equation true. First thing you want to recognize is that there is a log function on the left-hand side of this equation. And when you see this log function, you want to check its domain. So make sure you observe that 5x has to be greater than 0. That means we are looking for a solution where x is greater than 0. Let's proceed. For this equation, we could balance it by dividing the entire sides by -3. And if you do that, you will isolate a log function. That log function would be log base 2 of 5x is now equal to -4. By definition of log, we can now write 2 to the -4 is equal to 5x. But 2 to the -4 is just 1 over 16. And that's equal to 5x. Divide the entire sides by 5. And you gotta remember, dividing by 5 simply means multiply by the reciprocal. So x is equal to 1/16 times the reciprocal of 5 is 1/5. And we get x is equal to 1 over 80. Let's circle that to be our final answer. Example B. How is this problem different from the first one? Well, there is a plus sign here. That changes everything. Why don't we balance the equation by adding 4 to both sides? Now we get what? Log base 3 of x plus 1 is equal to 1. By the definition of a logarithm. Oh, I knew it. I knew I would have trouble remembering this. We've got to check its domain. We want to make sure x is what? Greater than -1. We're looking for a solution where x has to be greater than -1. I'm actually going to go ahead and circle these. Those are very important. Getting back to our equation. By definition of a logarithm, we know that 3 to the first power is equal to x plus 1. That means x has to be what? X has to be 2. Is 2 greater than -1? It is. So we could circle that. Finally, the last problem here. We need to observe this domain, the domain of this function, I should say. The domain of that function. -5x has to be greater than 0. So when you divide the entire sides by -5, remember to switch the sign. So x has to be less than 0. We're looking for an x value that is less than 0. Once again, I'm going to circle that. That's very, very important. Let's proceed. Log base 2 of the opposite of 5x is now equal to 4. By definition of logarithm, this is 2 to the 4th power is now equal to 5 times x. Well, you should divide the entire sides by 5, because 5 is not 0. Let's find x. X is now equal to 16 over 5. And is that less than 0? And the answer is no. Not a chance. 16 over 5 is not less than 0. So what is our conclusion? No solution. Now, it's really not exactly about the answer. Make sure you show your work. This work is very, very important. So I'm going to circle this as well. Not many people are reading answers. We're actually reading your work and reading your procedures and your logical thinking and your precision and your attention to details. Solve for x. Base 13 raised to the 9x is equal to base 5 raised to the x minus 9. These are not common bases. In fact, 13 is a prime number and 5 is a prime number. But we are going to apply a logarithmic function to try to solve for x. Why don't we take the natural log of both sides? So we take the natural log of 13 raised to the 9x. And on the right hand side here, we're going to take the natural log of 5 raised to the x minus 9. And now we'll use exponent properties to simplify this. I'm sorry, logarithmic properties to simplify this. So we'll take that 9x and move that to the front. So we have 9 times x times ln of 13 is now equal to the quantity x minus 9 times the natural log of 5. Our goal is to solve for x. So let's try to collect like terms. We have 9x natural log of 13 over here is now equal to x times the natural log of 5 minus 9 times the natural log of 5. We're trying to get the x's together. So let's do 9x ln of 13 minus x ln of 5 is now equal to the opposite of 9 times the natural log of 5. We have a greatest common factor here of x. So why don't we simplify that? We have x times 9 natural log of 13 minus natural log of 5 is now equal to negative 9 times the natural log of 5. This here looks like the natural log of 13 raised to the 9 over 5. Yeah. Is equal to negative 9 times natural log of 5. Let's see. What else can we do? We're going to divide the entire sides by this number here. Natural log of 13 raised to the 9 over 5. And if you do that, we finally get an x. X is equal to negative 9 natural log of 5 over natural log 13 raised to the 9th power, I said 13, over 5. And that is acceptable. That is as simplified as we can get it. That is an exact answer. I'm going to circle that exact answer. And of course, make sure you show all your work to get there. Sample B is going to be similar. You could pause the video and give it a try if you want. I think really a key step here is don't forget those parentheses. Those are mandatory. Those are necessary. Okay. What's another way of writing this? You could write this as well. Five to the third power, which is 125. 125 is not divisible by 2 and not divisible by 3. So we know that's done, or I should say we know that is reduced. Reduced, past tense. Let's circle our exact answers. So it could take on slightly different forms, but both of those to me are acceptable. Notice this is what we call an exact answer, and this is an exact answer. So we often find the exact answer first before we even try to find the decimal approximation. As usual, show all your work, show all your details very neatly and orderly, and make sure you understand that for this problem, or for these two problems, you're solving equations. So every single line of your work is an equation. Even your answer that you circle is an equation. So with equations, we simply balance equations to write another equation. Let's solve these equations. These types of problems are really used to get you for the computations that are done in calculus. We're actually going to perform a calculus technique here called U substitution. So for part A, there's an equation there, and it has an interesting pattern. E to the 2x minus 3 times e to the x minus 28 is equal to 0. The pattern here is that once you let your u sub take place, let's say let u equal e to the x, we're going to rewrite the equation using the letter u. Notice u squared is what? U squared then is equal to e to the 2 times x. Hope you guys can see that. U equals e to the x, and then you square both sides. And when you square both sides, you get u squared is equal to e to the 2x, like that. All right, we're ready to rewrite the equation. Rewrite the equation with the letter u. So this is u squared minus 3 times u minus 28 is equal to 0. And this looks very, very familiar. This is simply the u number line. Let's go u times u. And now we have 7 and 4. We need a minus 7 and we need a plus 4. I've checked it. My factoring is correct. Now we have u is equal to 7, or what? U is equal to negative 4. But we're not interested in u. We now need to back substitute u. This is e to the x is equal to 7, or e to the x is equal to negative 4. Now we'll go ahead and balance these equations by taking the natural log. Using the natural log function to both sides of the equation. So on the left-hand side here, we do get an x. And that's x equals the natural log of 7. What about this side over here? We got an issue here. E to the x is never negative. This is not possible. And a good way to see that is graph e to the x. You should know that basic graph by now. Have this memorized, especially for those moving on to calculus. That is your e to the x function. Notice it's never negative. It's never going to equal negative 4. Negative 4 is like way down here. That's not possible. So we only have one answer for part A. Simply x equals natural log of 7. What is the u sub in part B? What do you think? Should you let u equal 10 million? No, of course not. What should you let u be? Let u equal 10 to the x. And if you let u equal 10 to the x, then you know u squared is equal to what? 10 to the 2x. So let's rewrite the equation again. U squared minus 7 times u plus 10 is equal to 0. And I'm pretty confident that you could finish the problem from here. So you might want to pause the video and try to finish this on your own. Now this time you don't want to use natural log. You want to use base 10. So why don't we just use logarithm base 10 function. Let's use logarithm base 10 function. So we're going to write log of 10 to the x is now equal to log of 5. So this is really saying what? X is now equal to log of 5. Or what else do we have? Moving this equation down here, in a very, very similar pattern, we get what? X is equal to log of 2. Log base 10 of 2. There we go. So in this case, we have two answers. Circle those. What is your u sub, for example, C? You're probably seeing a pattern by now. Let's rewrite the equation using the letter u. U squared minus 18 times u plus 32 is equal to 0. And we get u times, well, we need a factor. We need two factors set equal to 0. In this case, we'll try 16 and 2 and subtract. So what do we have now? We have 2 to the x is equal to 16, or 2 to the x is equal to 2. You could apply the log base 2 function to both sides here. That's one way to do this. Why don't we try that? Just to maintain some consistency here. Why don't we try log base 2 function? Because it's base 2, we have to write it. Is now equal to what? Log base 2 of 16. But how am I going to rewrite 16? I'm going to rewrite 16 as 2 to the 4th power. That way, the very next line, I could write x is now equal to 4. Ta-da! In a similar fashion here, we could take log base 2 of this equation and we just get x equals 1. Invisible 1, there it is. X equals 1. Aha! So here we get two answers as well. Notice when you're solving equations, every single line of your work is an equation. Let's invest some money. Suppose that $5,000 is placed in a savings account at an annual rate of 4%, compounded quarterly. Assuming that no withdrawals are made, how long will it take for the account to grow to $7,225? Do not round any intermediate computations, and round your answer to the nearest hundredth. This is a finite compound interest problem. We need a formula, and that formula is A of t is equal to the principal times a principal times a base, and that base is actually 1 plus the rate divided by n raised to the number of compounds. So it will be n times t, depending on how many years you want to analyze this investment. We are trying to find how long will it take, right? Go back and read the question. How long will it take for the account to grow to $7,225? How long is a measurement of time? We're actually trying to find t. And usually with this problem, t is actually a measurement of years. Do we have a principal? Do we have a initial amount here? And the answer is yes. We have P right away. We know that P is $5,000. What's the amount that you want to gain? We know A of T is going to be 7,225. Do we know N? We also know N. Compounded quarterly means N is 4 times a year. All right. We could substitute everything. 7,225 is equal to 5,000. 1 plus, I need R as a decimal. 4% as a decimal is decimal 04, or 4 hundredths. we said n was 4. And then we need to raise this to 4 times t. Next thing you want to do is divide the entire sides by 5,000. Using the fraction button on your calculator, you get 289 over 200 is now equal to 1.01 raised to the 4 times t. I'm going to use the natural logarithm. I'm going to take the natural logarithm of both sides now. And we're going to use a logarithmic property to bring that exponent of 4t down. Right now it's sitting high, but we want to bring that down to be a coefficient. And if we do that, we're on our way. Finally, we could divide the entire sides by something that's not 0. 4 natural log of 1.01 is not 0. It's a very, very carefully chosen number to divide the entire sides by. Finally, we get t to be equal to the natural log of 289 over 200 all over 4 times the natural log of 1 and 100th. I'm going to circle this. This is going to be in years, of course. Don't forget your units. You got to make sure you remember your units. If you're going into business, if you're going to science, if you're going to mathematics, always label things. We don't want this to be milliseconds. Well, you'll be dreaming if you made this much money in milliseconds. We want this to be in years. Now, it does say round your answer to the nearest hundred. So make sure you can do this on your calculator. We're going to round t to the nearest hundred. First, we need the decimal representation. The decimal representation is 9.248, and it keeps going on and on and on forever. We need to round to the nearest hundred, so we need to look at the thousands place. The thousands place is an 8, which is more than 5, so we are going to round this up. T is going to be approximately 9.25. And of course, don't forget your units. Make sure you write your units on your piece of paper that you are recording your work on. Make sure you write the units. Now, if a problem is given to you in sentences, you should answer it back in sentences. It will take about 9.25 years for the account to grow to what amount? We're trying to grow this to $7,225. You're not quite rich, but still, you made some money. And for just letting the money sit there and you earning it, that's pretty nice. Suppose that $2,300 is initially invested in an account at a fixed interest rate, compounded continuously. Suppose also that after 2 years, the amount of money in the account is $2,434. Find the interest rate per year. Write your answer as a percentage. Do not round any intermediate computations, and round your percentage to the nearest hundredth. This is a continuous exponential growth. And we want to grow this account that started with $2,300 to $2,434 after 2 years. First thing we're going to do is write the formula or write the mathematical model that corresponds to these vocabulary words. That model is the amount of time, I should say that model is a function of time, which is equal to the principal times base E raised to the interest rate times the number of years or hours or days. In this case, it is years. Do we have a principal? We do. The principal amount is $2,300. We also know that A of 2 is given. A of 2 is given to be 2,434. We're trying to find the interest rate per year. So if you substitute A of 2 into this equation, A of t is equal to P times E raised to the RT, we get something really, really good looking. We get 2,434 is equal to 2,300 times E raised to the R, which we don't know, but we do know T. T is 2. At this point, we want to balance this equation by dividing the entire sides by 2,300, because 2,300 is not 0. Now we have 2434. 2300 is equal to e to the 2r. Actually, we should reduce that fraction on your left by 2. How about that? What happens if you reduce that fraction by 2, a common factor of 2? 2434 divided by 2, we get 1217, and 2300 divided by 2, we get 1150. Now we want to take advantage of the natural log function. We could balance both sides of the equation by taking the natural log of both expressions. We have 2r. Well, we have natural log of 1,217 over 1150 is equal to 2 times r. Divide the entire sides by 2, and we get r. R is equal to this. And now we need a decimal. So go ahead and use your calculator and get a decimal representation of this. The decimal representation is decimal 0.283133436, and it goes on forever. We're trying to round this to the nearest hundredth. So we're going to look in the thousands place. The thousands place is an 8, which is more than 5, so we're going to round this up. R is going to get rounded up to decimal 0.3, which you know that is equal to 3%. Oh, I'm reading this wrong. It says, round your percentage to the nearest hundredth. Oh, well that's very, very different. So we don't want to round this to 3%. Let's change this to a percentage representation now, r is equal to 2.831436 percent. Now we want to round to the nearest hundredth. So we're going to look at the thousands place of this representation right there. 1 is less than 5. So we are actually going to round this to 2.83%. If they give you a question in words and sentences, you should probably answer it back in words and sentences. The interest rate is about 2.83%. As usual, make sure you show your work to support this final sentence. Let's graph this system of linear equations, and we're going to attempt to solve it by graphing. Let's see how well we can do this. I don't have graph paper, so we're going to have to be even neater. The first equation is given in y equals mx plus b form, which is great. Let's write the second equation into y equals mx plus b form. The second equation looks like y is equal to 2x plus 7. Now I do need some marks here. I need a 1 here. I need to go up 7 as well. So that's 3, 4, 5, 6, 7. So here's 7 up here. Let's graph the first line using some red ink. Now the slope is up 1, right 2 for the first line. So I'm going to color this one in red. Up 1, right 2. From the y-intercept. The y-intercept is 1. And so it looks like I need those two right there. Let's play connect the dots. We also want to graph the second line. In order to do that, we're going to start with the y-intercept, which is 0, 7. And then we're going to travel a slope here of positive 2, which means it's going to have to be up 2 and then right 1. And we're going to connect the dots with a straight edge. It looks like this graph is actually, well, I should say, the graph of these two lines look to be intersecting in quadrant 3. And we need to figure out what that ordered pair is. That is our goal. We want to find this point of intersection right here. Not sure what it is. I know it's some negative x value. So our goal is to find that. So graphing, if you have graph paper, you could be very, very neat, and you could definitely get a much better visual. Instead, what I'm going to do is use a classic substitution method. I'm going to take equation 1 and substitute it into equation 2. And if we do that, we should be able to solve for one of the variables. Let's do that. Let's take equation 1 and substitute it into equation 2. So wherever I see a y, I'm going to put parentheses, 1/2 x plus 1, and now this is equal to 7. Let's use fraction busters. Let's multiply the entire sides by 2, and let's see what we get. Negative 4x plus an x plus a 2 is equal to 14. We get negative 3x is equal to 12. X is equal to negative 4. Now I'm going to put this x back into equation 2. So if you put this x back into equation 2, we get y is equal to 2 times negative 4 plus 7. So y is equal to negative 1. Does that seem reasonable? Yes. That is definitely an ordered pair in the third quadrant. So let's write our final answer. To write our final answer, we're going to write these little set braces. It's going to be a set containing a very unique ordered pair. A unique ordered pair. So one solution. Negative 4, comma, negative 1. So this is a set containing a unique solution. Circle your final answer.